Um, Hello, just doing the sound check.
Hello.
Hello, just doing the sound check.
Oh, we're already on.
Okay, hello everyone. Welcome to our July 9th Starry Night. It's great to be here again. For me, it's the second week in a row. My name is Rohit, but I know this is the fourth Starry Nights that we've had. So great to be here. I'm gonna pass it on to Zena, who's my co-host for today. So take it away, Zena.
Hello, everyone. This is Zena. This is actually the first time that I've co-hosted with Rohit because in the past, every time we are scheduled to co-host together, I always get canceled, and I was impressed this time it did not. So, yay! This time we get to do it. And I
Yeah,
would like to introduce our moderators. We have Matthew and Indira and Haley from RAS.
thank you so much, Zena. Yeah, you're so right. Anytime we've prepped and we're ready to go, it turns out that the night's been canceled. And if someone just heard a train noise, I do apologize. I do live near train tracks, so this is the 10 o'clock train, cargo train that's gonna go by. So yes, I do apologize for that. But
Okay, Rohit, don't worry. It adds up some sound effects to our stream.
yeah, I hope it wasn't too loud, but that's okay. Um, okay, so the first thing I just wanted to kind of start off with is I just wanted to give everyone a brief update of what's happening around in our solar system in terms of planets. So in 2011 we had Juno, which was launched, and it reached Jupiter in 2016 with a goal to study the planet's formation and evolution. In addition to that, it was also going to study its magnetic field, the atmosphere, the composition of the planet itself, and also sort of the evolutionary stage that the planet went through. And just recently, it had a really nice picture that it obtained of one of the moons of Jupiter. Now, the four prominent ones are Io, Ganymede, Callisto, and Europa. And Juno was able to get a really nice image of Ganymede, which is sort of the icy giant, or it's the icy moon, as we like to call it. And the image was actually because of a flyby. So the way it works is the satellite is in orbit around Jupiter, and often it'll do a flyby with its satellites, which which are the moons in this case. And we were able to, and it was able to obtain a really nice image of Ganymede. Um, and there has been some updates from Mars as well in terms of the Ingenuity helicopter making more strides. But I just wanted to go a bit off tradition and talk about Jupiter because it's I would say it's probably my favorite planet to look in the night sky. So I think it would be that's why I just wanted to sort of include that. Um, so yeah, did you have anything to add there, Zena, about Jupiter?
I would say I want to try to remember which planet that I saw through the observatory. I think it was Jupiter. I honestly, if I had to pick a favorite planet, I would say Saturn. Saturn is just because I like the ring, and it gives with Saturn, it gives that 3D effect when you look at it through the telescope. While all the other planets you still see as a 2D, That being said, I like Jupiter. You can see the colors, and you probably, if you have a really nice telescope, you can see the red dot. But,
Yeah, no,
but
it's, oh, I think hopefully, well, I hope we didn't lose Zena here, but no, she is definitely correct regarding how nice it looks through how nice Saturn looks through the telescope as well, um, and just how inspiring it is to look at a planet, right? I mean, these objects are quite far away from us, but at least we are still able to look at them using telescopes, which I think is fantastic. Um, so yeah, next what I wanted to show everyone is one of the stars which is quite prominent in our night sky right now is Altair. So this is actually a star in the constellation Aquila. Now, if you just bear with me a moment, I'm just going to get the telescope to slew onto the target. Um, so this is one of the softwares that we're using to control the telescope, and we just kind of type in the object that we want to look at. In this case, it's Altair, and I'm just going to get it to slew. And once it's done that, we should have an image of the star in our center screen. So I hope everyone is able to take a look at that. So this is actually, as I mentioned, a star in Aquila. The star itself is roughly 16 light years away. Um, and this is actually a pulsating variable star. Now, um, perhaps the question is, well, what is a pulsating variable star? Um, so, so Altair is actually a very unique star in terms of the way it is, because um, this is one where it actually, the star will swell and shrink, which will actually end up affecting its brightness and also its spectrum. And in addition to that, it's also the star also has a really high rotation speed, and because of that, the poles of the stars are actually a bit flattened as opposed to our sun, where the poles are a bit spherical. So there has been really images that Altair that they've taken for Altair, and it does show how the poles of the star is actually flattened as opposed to our sun. Um, and it's also one of the hotter stars as well. I believe the temperature is around 7,500 Kelvin to about 8,000 Kelvin. So it is one of the hotter stars out there as well. So um, it's prominent in the night sky. I mean, and Altair is actually it actually forms a part of a great summer object to look at, which is the summer triangle. It's not per se on any sort of messier list or anything like that, but these three stars, which we'll discuss today as well, they form a really nice they form a really nice triangle in the night sky, and it turns out to be quite a spectacle as well. So yeah, Zena, did you have anything to add on that, or perhaps we can go on to the next star in part of the summer triangle?
yeah, let's do that.
Okay.
That was very well priced. I like it. I like the explanation you gave on the pulsating variable stars, because I feel that's maybe most our audience who are not familiar with that. They won't know what a variable star, or maybe they'll have different maybe thinking of what a variable star means. At least I would
Yes.
have never, if I hear it for the first time, I would have never associated with brightness. So that's when a pulsating variable star. The easy way of saying it is just change, like the brightness of the star changes over a period of time,
Hmm.
and over our lifetime, like we can actually, like scientists can actually observe how the star changes in brightness.
Right. Yeah. Um, no, I mean The stars, all of the stars that we have in terms of their various characteristics, they're quite a lot in terms of um, some of them are Cepheid, some of them are variable, some of them are pulsating variable. So yeah, it's nice to know that the information is at least appreciated. So yeah, I just wanted to point out actually, because I know we won't be able to see the triangle with a telescope, but this is actually a naked eye observation that you can make. So I'm just going to use our star chart here, which we use to get the telescope pointing in a certain direction. And you'll notice that if we draw a line from this star right here, which is Altair, all the way next to Deneb, and this third star, which is Vega, and back to Altair, we end up with this triangle. And this is what I was referring to as the summer triangle. Now, obviously, with the telescope, it's quite hard to do that because the telescope is, looking in a specific direction and in a specific area. But it's a really nice naked eye observation that you can make in the summer sky. So, not to hold it any further, I'm going to move to Deneb, and I'm gonna have Zena give us a summary on Deneb as well. So it's all yours, Zena. Once we are in this direction.
Just want to say one more thing about variable star. I maybe already mentioned it, I'm not sure, but just to point out, our sun is not a variable star. Our sun doesn't change in brightness. Just to
Yes.
just to keep in mind, in case if people are wondering about our sun. Yeah, so Deneb is actually like he meant like Rohit mentioned. It's one of the three stars of the Summer Triangle. It's actually it's the brightest star in constellation Cygnus or the Swan, and Deneb is about, I think it's 2,600 light years away. That means this is how long for that light to reach our eyes. It will take that many years. And interestingly, Deneb is derived from an Arabic word called the tail of the chicken. I'm not sure why exactly, but if I were to guess, maybe because maybe Cygnus means swan, so but I don't know why they would call it the tail of the chicken. So maybe it's just a different cultures how the naming came about. Yeah, they're all birds. They're all deriving bird words, if that makes sense. I just thought it was funny that the word deneb means the tail of the chicken. So, and also the deneb, the star itself, it's a blue super giant. So I'm not sure how many of the audience know about the different types of stars and how the color reflects their temperature and their age. So, for example, if our sun is part of what's called the main sequence. It's a main sequence star, and so it's considered a low, medium-sized star. While this star we're looking at right now, it's a blue supergiant, and blue stars tend to be very young and very, very hot, and they're not within the main sequence stars. So what I mean by that, it's when you think about the cycle. So what the stars will transform into something else, like they will have fates, and the fates we have, they would either become a white dwarf, or a neutron star, or a black hole. So for the high mass star, like this one, the one we're looking at, like Deneb, it's destined to become either a black hole or a neutron star. While our sun, because our sun is a low mass star, it will be destined to become a white dwarf. Just to give that kind of distinction for anyone who doesn't know about it. Do you have anything to add to the different types of star, Rohit?
I mean, wow, Zena, that's such a great explanation. I don't know if the audience knows this or not, but I mean, I started in amateur astronomy, as I like to say it, after taking Dr. Howard Trottier's course in Intro to Astronomy, Physics 190. I still remember this was fall 2009, and one of the things that we talked about was the HR diagram, which we refer to as, like, I believe it's the Hertzsprung-Russell diagram, which kind of talks about the main sequence of stars and where they are in their stellar evolution. And you just brought me back to that class with this explanation. So kudos to you. Yeah,
Thank
I think no, you said it right on there. In terms of stellar evolution, how sometimes they'll go into you know they'll expand and it'll be a supernova, or eventually the possibility when it reaches a uh, certain mass times of the sun, it'll become a black hole. So yeah, it's yeah, you definitely brought back memories of, I guess, now 12 years ago or 11 years ago. So
definitely,
yeah.
but I'm sure they are good because it's with Dr. Trottier. Of course, they're good memories.
Yes, yes, absolutely. I don't know much about the memories of writing midterms or something, but apart from that, other than that, it was really nice.
Oh,
It was great memories.
what's his
Yeah.
test like? Was he hard? Was he a tough teacher or professor?
Um, you know what? I think no. If I remember correctly, we had, I think it was two midterms and maybe a final and some assignments, and but it was all very fair. I We didn't. We had a lot of interactions because we did have observing sessions as well. That was part of the class, and together with him, we volunteered for the first astronomy day at SFU back in 2009. That was the first astronomy day event, I believe, at SFU as well. So it was a lot of fun, but I know I don't think he was a hard marker. And then again, I don't know how he was with his upper level courses, but going back to going back to this, no, I think it was great. We had a lot of fun. Yeah.
Awesome. I think most of us, well, not me, but most of the people who joined the Trottier Observatory, being part of that community, they all took, I think, Howard's classes, and that's how they. For me, it was. I actually don't know how I ended up because I didn't take any of his classes. I feel I was just invited to come when the observatory was built, and it was
Hmm.
actually not like it was, the opening was on my birthday, so I
Oh.
will forget that. So I think it's just he asked. I think there was an email. They were asking for volunteers, and I was one of the people who showed up to every time they wanted a volunteer. To do the um, just to to moderate, but in person.
Yes.
And one day he said, "Zena, do you like to work for the observatory? Do you like to get paid for what you do instead of volunteering all the time?" And I said, "You know what? I'll still do this for free. But I'm okay if you want to hire me and give me money, but I'll do it for free regardless."
Yeah, no, it's great to know that we all kind of share that connection as well. I know we've built great relationships while being at the observatory, but it's nice to hear that we all have sort of some sort of connection with Dr. Trottier. But but yeah, Zena, did you wanna should we move on to the next star in the summer triangle?
Yes, yeah, let's do that. Let's go. Let's go to Vega.
Okay, sounds good.
Vega. One of my favorite stars. I don't know why. I'm not sure how it ended up being one of my favorite stars. Just, I think Vega is one of those stars that looks pretty to look at with the binoculars, and
Oh
you
yes.
can also see it with the naked eye.
Yeah, and I
But
mean it's actually a really bright star as well, right? Because I mean you just step outside and you look in the direction, um, uh, if you look in if you look in the direction uh, of west, and you would be able to just see it right over there. It's like a bright star, and it's right over there. So yeah, let's see if we are able to see this over here. So yeah, take it easy now. We are at Vega now.
thank you. Yeah, the star is 25 light years away from Earth, so it only takes 25 years to reach our eyes, the light, which is amazing. So it's a close star. Actually, yeah, the most fascinating fact about this star is that this star was the North Star 12,000 years ago, which is I find that fascinating. When I was like, what? Well, I thought Polaris is our North Star, but nope, it actually shifts. Like our North Star shifts over thousands of years, over certain periods of time. So in I don't know how many years, I can't remember the exact number, but I'm gonna assume maybe in maybe thousands of years later, maybe 2,000, or no, sorry, 12,000 years later, it will be a different North Star other than Polaris. And I was trying to figure it out why do we change North Stars? I just find that so fascinating. And I learned that the Earth axis wobbles. But it wobbles really slowly. Like the wobble goes over like thousands of years. That's just how slow it is. That's why it switches. Like when it wobbles, it switches between North Stars. When I say switches, I mean the axis of Earth. Our Earth axis switches. And I think there is a video that we can take a look at it to explain, to show what I mean, how the Earth wobbles, how it switches between the North Stars. Do you have that video, Rohit?
Yes, I do. Just give me 1 second. I'm just gonna put it up here. We may not be able to get audio, Zena, but let's try. I think the video hopefully is able to describe it.
I think we just need the visual of it.
Yeah, so what's happening here is that, we lie in a certain, as the video talks about, we lie in an elliptical plane as well. So as the Earth is moving around on its axis, as Dina mentioned, does the wobble effect. So because of that wobble, uh, the way we are pointing north will will change. It happens, as she talked about, it happens over thousands of years. So, right now it's Polaris, and in 12,000, in 14,000 years, it'll be Vega. And I think the video is doing a really good job in terms of explaining how that is kind of happening in the night sky as well.
Very fascinating. Kind of makes me wonder. So, like, how long will it be the next? Like, who? If my grandkids, great grandkids, will have a different North Star than the star I saw. You know, like if I can go back to my ancestors and think, oh, this great grandfather saw the Vega or used Vega for navigation.
Yeah, I mean, it's fascinating, and the one thing that I really love about astronomy is, I mean, whenever we're looking at the night sky, we're looking at a time machine. I mean, like, take a look at the sun, for our own sun, for example. It's the light from our sun. It takes 8.3 minutes to reach us. So the image that we're getting from the sun, it was 8.3 minutes before than it actually was. And the same with Vega. I mean, we're looking at Vega as it was 25 years ago, because the light from Vega, it took 25 years to get to us, and that's what we're looking at. So it's almost like just looking at a time machine, right? So I know in my early days when we used to do Starry Nights, we used to joke about how if the sun ever explodes, it'll take us 8.3 minutes to realize that the sun has exploded, because that's how long the light from our star takes to get to us. Um, so yeah, definitely, as Zina mentioned, definitely interesting times.
Oh, for sure. Yeah, whenever I think about space, one of the fascinating thing about space is the aspect of time and light, how they're both like together associated. Um, yeah, I really like this video. It's so good. It's very well graphed.
I think it gave it. I think it gave us a really. And if I can pause it in time, there we go. Before the ads, I think it gave us a really nice description, Zena. So yeah, was there anything else you wanted to add on that, on Vega? I know, I know we tried our best to have as much information as we could. So yeah, was there anything else you wanted to discuss on Vega?
Well, okay. So Vega is what the name itself, like where it's coming from. It's actually Vega means sweeping vulture, which I saw. I was like, oh, this is like again the bird names coming up. And then I find out like Lyra is actually a name of a bird in other cultures. It's like, okay, this is very interesting. There is the bird theme with those three stars, the summer triangle. I'm wondering why is it called a triangle when they could have even added another bird name to it. That was just I don't know. I just thought it was funny. Actually, interesting thing about Vega, it's the first star to have a spectrum photograph. So when we do spectroscopy, you need to have a star as like for calibration or as a default. And because Vega was the very first star to be photographed or to have the spectrum, it became the default. And the point of having the spectrum is to get the brightness of the star. So Vega has a magnitude of 0, and any other stars that other than Vega, it will be with respect to Vega in terms of brightness.
Wow,
Does that make sense to you, Rohit? Is there anything I should add to that?
no, I think that's great. Yeah, you're definitely on point on that. I mean, for me, the reason why I like Vega a lot is because it was featured in one of my favorite movies, Contact, and you know uh, the premise of the story is that they've sent sort of radio signals out in space, and we've received a response from uh, received a response from Vega. So there's that aspect of that star in that movie as well. And the interesting thing about this star is also which was an inspiration in the movie as well. That there's actually a dust disk observed, which might be debris as well. So there's no, I mean, as far as we know, there's no planets that were observed around Vega, but it was sort of it's more sort of a protoplanetary disk that was observed uh, when we did. So yeah, it was a really cool depiction in the movie as well.
Nice. We never know. Maybe the planet is still there. Maybe it's just too small to be detected. Because usually when for
Yeah,
detecting planets, they have to be the size of Jupiter. Maybe they're just smaller than Jupiter. Who knows?
yeah. I mean, let's see how it pans out. I mean, that's what I always like to say. You never know with the advances that we're having. So
If you live long enough, or at least one of your grandkids live long enough to witness that
yeah.
planet or aliens coming from Vega.
Yeah, I know you're absolutely on point. So I know we've kind of talked a lot about the stars, and the reason why we like to start with this is because um, the other thing about having observing sessions in the summer is we kind of have to wait for it to get properly dark. Now, you know, in Vancouver, we get maybe 2 months of, proper clear skies when it's in the summer. However, there's that disadvantage where it doesn't get, super dark until later in the evening. So I think right now is probably a good time where we can start looking at, maybe we can start off with clusters, globular clusters, and then we can move on and see how things progress. Of course, in the fall and in the winter months, this is not a problem. We get darkness at about 5 or 6 p.m., and we are able to uh, turn on the observatory. However, there's that big factor of the weather, because if it's raining, then there's no observing happening at all. So the summer months are great for observing and doing things, but of course, there's that trade-off uh, with with how dark it is. And I'm just looking outside my window as well, and yeah, it's not fully dark yet, so we'll see how we pan out with the clusters. What do you think, Zena? Is this a good time that we can move on to them?
Yeah, I think clusters. I think they should be fine because clusters is just it's a cluster of stars. So I think it should be okay moving from one star to a cluster of stars. I think we'll be good.
Yeah,
Let's do it.
yeah. Let's hope so. Let's see how it goes. Okay, so the first object we're actually going to look at is. I'm sorry, Zena. I know you wanted to talk about this object, so go ahead. Go
Oh,
ahead while I get the telescope in line.
sure, no worries. So we're going to M3, which is a globular cluster. So for those of you, I'm not sure if you know what. I think every session we always talk about what the M stands for. So M refers to messier. It's a messier object. So it's referring to the astronomer who discovered or cataloged those celestial objects in the night sky, and he's a French astronomer called Charles Messier. So he's a very interesting person. He was trying to find comets, and so what he did, he was every M, when you see that M catalog, it's a non-comet. So he managed to find everything but comets, which is, I find that very, very hilarious. That all this hard work, his work was still very, very rewarding for us, but he didn't succeed in getting a comet. But I don't know how I would feel about that.
I mean, he did give us a lot of favors in terms of being able to catalog everything, and we now have 110 Messier objects that we have in the night sky, and then that sort of has transformed into the new general catalog of objects. It has transformed into the Caldwell catalog. So a lot of that has been kind of changed over the years, but you are correct, Zena. I mean, he tried his best to look for comets, and it just doesn't happen. And it was sort of a way for for him to tell other astronomers that, hey, don't look in this part of the night sky. You're not going to find a comet, and it's not a comet. It is actually just a nebula or a galaxy. Oh, sorry, a nebula or a cluster or something like that.
Yeah.
So that's why it was good on him to kind of do that work for us, as opposed to someone uh, as opposed to someone doing it all over again. Um, so
That's
yeah,
true.
while I try to clear this object out, just because we are using sort of a camera to uh, for everyone to be able to see this object. Um, so while we're doing this, just bear with me a moment. And I just looked at the chat, and it looks like so Zena. It looks like actually Charles Messier, he only found 7 comets in his lifetime.
Oh, really? Oh, I didn't know that.
Yeah. So
I
Abby just posted in our chat, and that's
thought it
great. I
was
mean,
funny that he never found the comets. I thought that was the joke.
no, he did
That
it.
was
He did end up
no.
finding some comets, but it were only 7.
Okay, seven is better than none. I think that's a good accomplishment. Not only he get to have he cataloged all of these and like 104 objects. He gets to have 7 comets. I think that's a great accomplishment for him. But yeah, actually, interesting thing about this cluster we're gonna look at is actually the very first object that he discovered. Even though it's called M3, which was for me when I read this, it was so confusing. It's like, if it's the first one, why is it M3? Why isn't it called M1? And it turns out he discovered it, but he didn't catalog it until later, so that's why it's called M3. So it was the third one he cataloged, even though it's the first one he discovered. If that makes sense to the audience. But yeah, does that make sense to you, Rohit?
Yeah, it does. I think, if I remember correctly, I think M1 is the Crab Nebula. If I'm,
Yes. M1 is definitely the Crab Nebula.
yeah, if I remember correctly, yeah.
It's a nebula, yet it's actually a supernova.
Oh yes, yes, you are correct. Yeah.
It's always
Um,
fun kind of
so
naming
yeah,
confusing.
just bear with me while I try to clear this out. So one thing we just have to kind of, one thing I just want to let everyone in the audience know as well. Uh, you know, there is quite a lot of light pollution in and around Burnaby, where the observatory is located. I mean, it's great to have a telescope on a mountain. However, it doesn't help if there is a lot of lights around the mountain, because we want the telescope to get the light from the night sky. We don't want the telescope to get any scattered light from the lights around Burnaby Mountain. So yeah, we will have some effects of light pollution as we attempt to clear this image out. Okay, so we are not stacking for some
What
reason.
can we do
So
to create to get the no light pollution?
yeah, I think that would be really hard to do, Zena. You are correct.
Ugh, and we're having more of the campus lights, which doesn't really help our purpose to show. But at least we're getting something. Other interesting thing about globular cluster. So globular cluster, they are, as you see from the photo, there's a lot of stars. They're all clustered together. So for some reason, those stars, they are gravitating towards each other, and I honestly don't know the reason why. I originally thought maybe there was a black hole in the middle of it, like somewhere in the center. But then when I think about open clusters, which are the kind of they're younger in age, so it just means like at some point the open cluster will become a globular cluster, and they haven't detected any black hole in that area, so I'm not sure why they're gravitating towards each other. So with globular cluster, the interesting about them that they are closer to the age of the universe. So our universe is about 13.6 billion years in age, and this globular cluster we're looking at, it's 11.4 billion, which is very cool. And this globular cluster is about 34,000 light years away. So that means, since we're talking about the concept of time just a few minutes ago, it took 34,000 years for that light to leave from that area, wherever the globular cluster is, and to reach our eyes. 34 years. So if you were to think about it, whatever, like right now in the present time, this globular cluster might look different. So we're looking into the past. Like when we say it left 34,000 years ago, we're looking, this image is in the past. It's not the present. Who knows? Maybe in the present there's just more clusters of stars. Who knows?
Yeah, so you make a good point about the globular clusters. You know how they are the older objects in our universe, and what ends up happening with globular clusters is because of the mutual gravity between these stars, they tend to attract each other. And what ends up happening is that's why you'll have a dense core in the center, where the center, so for example, this globular cluster, it has approximately 500,000 stars. And there's more, uh, the stars are closer to each other uh, in the center as opposed to the outside, which you can kind of see in this area where some stars are far away, but when you go to this cluster, when you go to the center of this object, you can see how they are very close to each other. So that's where sort of gravity plays a role, and it kind of puts everyone um, in one area, as opposed to spreading everything out. So yeah, that was you are definitely right in terms of the age and how it sort of represents in the night sky, and also how it represents to the age of the universe. So yeah.
Yeah, so it's also like if you're not sure, you can also look at like how can we tell like how old an object is by looking at the type of stars that are in there. Or this is one of the indication that could give you a hint. So some with the globular clusters, the older stars tend to be red, orange color, and the younger stars tend to be blue. So blue stars are young and red stars are old. So if when I look at this, so in the globular cluster, you'll see mostly red stars or red orange stars, and in an open cluster, I don't think we're going to show an open cluster today. But if we were to show an open cluster, you'll notice that the open clusters are mainly they're mainly blue stars, which
I,
kind of makes sense. So it does reflect kind of the age of that cluster.
I actually did have an open cluster in mind, but let's see how the night goes, Zena.
Oh, okay, sure, sure. That's awesome.
Yeah, so the one thing I wanted to also talk about is about sort of the process that's happening here. So it is really different when you look at this object using your telescope or using binoculars, as opposed to when we are using our software here, which is giving us the ability to stack these images. I know you may have just briefly seen that I kind of closed off this warning message, which is telling me that it's not stacking, but yeah, we'll have to see how that one pans out. But when you are looking through this object in the night sky, sorry, when you are looking at this object using your telescope or binoculars, it's going to look very different to what it is as we're looking at it in the software. What the software is doing is taking sort of snapshots of this object, and it's layering them. and with the software, we're able to sort of subtract the surrounding glow and remove all of that areas which we don't want in our image, and that way we're able to see at least this object. I can guarantee if we do hopefully soon end up at Burnaby Mountain sometime in the fall with our own telescopes, this object will look quite different as opposed to looking it through the observatory. Um, so yeah, I had. I'm just looking at the chat, and someone just asked which deep sky object we're looking at. So we're looking at M3 right now, and then we'll move on to a different one. Was there anything else you wanted to kind of share regarding what we just talked about, Zena?
With regards to M3, no, I think I hit all the interesting information about it.
Okay, great. So the next one that I actually wanted to show everyone was it's actually another globular cluster, and it's actually not. We have to go back to Vega for that because it's in the constellation Lyra. So allow me just to slew to that object, and
Yes.
then we
Go ahead.
can.
Are you sure you're not from Vega and you're not letting us know?
No, I assure you I'm not. If I was, I'm sure it would have been discovered by now.
Okay, okay, that's what they all say. I'm just kidding.
I mean, that would be something, right? Like an alien living among us, or an extraterrestrial. I shouldn't say alien, my apologies, but an extraterrestrial
I don't know how
living among us.
reptilian. Oh, they look like people, or they can look like people.
Yeah, I mean, anytime we talk about extraterrestrials, I always go back to the older Men in Black movies, or even I know, of course, the big one is E.T., but yeah, there's so many out there at this point. Um,
Was
but
there
yeah, so
it's called The Think? Was there a movie called The Think? Was also an alien movie, or does it have a different name?
oh,
What?
was
No.
it? Yeah, I'm not really sure. I don't remember. I don't remember ever seeing that one.
Was it called The Happening? I mixed up between movie names, but I remember. Well, actually, I won't say. I don't want to spoil it in case people haven't seen it. It's an old movie, but there was a shocking thing. Like it involves a dog, and I was shocked when
Oh,
the dog.
Zena,
I don't know. Yeah,
maybe you're confusing with horror movies and extraterrestrial movies. Maybe that's what's happening here.
maybe. Yeah, it was an alien movie. I like the one with Ripley. That's probably my favorite alien movie.
Okay. Um, okay, so we are at M56 right now, and let's see how this one goes. I really hope the stacking is working today. I really hope it works today. I don't want to go through this unfortunate issue that we had last time as well. But let's see. Oh, we do have something. So let's see how it.
Looks good.
Yeah, let's see how much we can clear. And again,
You have that light coming from the campus light.
yeah. So I mean, the telescope right now it's pointing towards east, I believe, and that's where we have a lot of light pollution, unfortunately, as well. So we'll do our best to clear this up as much as we can. Um, and again, maybe there are some frames that we may not be able to stack, uh, uh, just because of the light pollution. But let's see. So an interesting thing about this this globular cluster is that this is also one of the older ones. The age is 13.7 billion years old, very close to the age of our universe. And the distance from this point of the cluster towards the end, it's roughly 84 light years. So it takes 84 years from light from one side of the cluster to go to the other side. So it just sort of shows that it'll take a lifetime of human, human life for light to make from one end of the cluster to the other. And a really interesting thing about this object is, and the reason why I wanted to, the reason why I brought this out as well, is it has 12 variable stars, and out of the 12, one of them is actually a Cepheid variable. And I know we briefly talked about the Cephids when we were discussing Vega, Altair, and Deneb. So the SFU Observatory, we've actually done a Cepheid variable project, and Xena was actually part of that project, um, including myself and also the moderators. So what we did was we looked at the famous Cepheid in the Andromeda Galaxy, which is M31 underscore V1, I think, Xena, if I remember correctly. And that was the one that Hubble found, and that's his famous Cepheid variable. And that's what he used to determine the distance to the Andromeda Galaxy as well. And we did that. We did that study at using our observatory, and we published it as well. And it was I believe in the Royal Astronomical Society journal. Um, so yeah, that was a really fun project because we actually made a short a short image, or sorry, a short video of how the Cepheid changes in brightness based on its cycle throughout the month. So yeah, that was very interesting for us to do. Um, do you remember that project, Zena?
Yes,
Yeah.
I remember it. I'm trying to think where's the paper because I know it got published, and it's funny how because I did my master's, and usually when you like do master PhD you have to publish, and the interesting thing I published, or I was yeah I published with the observatory before my master's project, which is interesting. Yeah, I like, but I feel lucky to be part of this community. I didn't expect any of this. I'm just happy to be here and talk about space.
Yeah,
I mean,
I remember I remember going through that project, and I know for some nights we were at the observatory at midnight until 2 o'clock in the morning or 3 o'clock in the morning, just gathering data because of the way it was, and obviously now with the virtual environment, it's a bit different, and it's also easier, I would say, just because we're able to control it from our own. From your own residence, but I do miss being there as well, and uh, but yeah, so this was Messier 56, which is another globular cluster, and I think we just have we do have a lot of time here as well. So I quickly want to just show an open cluster as well, um, because that will sort of give everyone an idea on how different it is between a globular and an open cluster. Um, so yeah, sorry, Zena, I'm just moving to another target, but I hope you didn't have anything else to say in that part for M56 and our CFID project that we did for Andromeda.
trying to think what we did. So I remember I was more part of the imaging because there's two parts. There's the spectroscopy part and there's the imaging part, and I think I tried both. And I was kind of excited for the spectroscopy because because with spectroscopy you get to see the spectral lines and you get that spectral data, and usually like the spectrum you get to see the first when I hear the word spectrum I think of the rainbow colors, and so that was the thing. I thought like, okay, we're gonna do spectral analysis. I thought I'm gonna see like some colors, the rainbow colors, but that wasn't the case. Which we only got numbers. So apparently every color represents a number or a certain digit number, and I thought, oh, okay, that's okay. I was slightly disappointed. It's like I was hoping for something more visual, more colorful, but apparently it turns out that number gets translated into a color later on. But
Yeah,
yeah,
so I think if I yeah, if I remember correctly, we did. I definitely remember the imaging part because I know for one of the nights I was there until like 2 o'clock in the morning, and I
yeah.
had to scrub the first set of data because and you know what, I remember what it was like. It ended up happening that a plane passed by a couple of times, and that entire set was just and it was, you know what, and maybe it was just coincidence, but the plane just flew by directly in front of Andromeda, and it just ruined the data that we needed from the CFID. So, uh,
Yeah, that happens. Or a bird. Most in my case, it's always a bird.
right.
I don't or like the cross. I don't know what they're doing. And sometimes when you open the dome, they just sometimes I don't know what happened where there actually a bird did actually come inside. I don't
Oh,
know
okay.
what happened. I can't remember, but I heard the story. And sometimes they do sit at the opening of the dome, which is so annoying.
Yeah,
So
I remember that night like just like it was yesterday, to be honest, and I was very upset just because I had to stay extra and get the data done. But you know what, it's fine. It was for a good cause, but
you got
I
published. That's what it matters, and your name is in it.
yeah, yes. I mean,
So
I think it was more about just seeing how close we were to the actual um, like yeah,
value.
just to see how close we were to the actual distance of Andromeda. I mean,
Yeah.
after doing all of that study, and I think we got to, I think it was like 2.6 or 2.7 million light years plus or minus one or two based on the error percentage or something like that. So I mean, we were very close. Like we were right in that range, because I think that, so the distance to Andromeda, it's about 2.5. So we were right in that range in terms of what we found um, as well. Um, so yeah, while I'm clearing up this image, so as you can see, this open cluster is quite different to what a globular cluster would be. You can see in this image here. Um, let me just zoom
So
out.
if the open cluster includes those bright ones, because I'm seeing 1, 2, 3, 4, 5, 6, 7 bright ones, or does it include other stars?
Yeah, so Zena, you're right. Like, so this entire region itself is the open cluster, and just the remarkable differences between the open and the globular, right? So I mean, this one, the cluster itself is 1,000 light years away, um, and this one was actually discovered by, not by Charles Messier, but a Frenchman by the name of Guillaume Le Gentil, and then Charles Messier added it to the catalog. And what we're seeing, sort of this orb around this cluster, is some of the light pollution that we're getting from that area. Um, and I don't think we're close enough to, because I know there is another deep sky object in that region, uh, but I don't think we're there yet, or we would have been getting that as well in the view, but that's not the case. It's more sort of the light pollution that's in that region right now, unfortunately.
Yeah.
Um, but yeah, I mean, this is one of the as I mentioned, this is one of the newer clusters itself, and I believe the age itself is I think it's only like 200 million years or something like that, if I'm not mistaken. It's very young. Um, so yeah,
That is
it's
young in
uh,
comparison to a globular cluster where it's in the billions of years.
yes, yeah. So the estimated age of M39 is between 200 to 300 million years. I know on our scale that's a lot, but in the universe scale, that's nothing. Where the age of the universe is 13.8 billion years old, and this cluster is only 200 million years old, or 200 to 300. So yeah, this is sort of the difference that ends up happening between the globular and the open cluster. Now, one thing I just wanted to say is that if you are able to, open clusters are great targets to look at through binoculars and even small sized telescopes, because you are looking at in an open area of the night sky. You'll get a lot of light coming from that area. So and the views are quite nice as well. So I urge everyone, if they are able to go and look at some of the open clusters uh, that we do have right now in the night sky. Um, I know, of course, we all have. Uh, I shouldn't say that. Maybe all of us don't have smartphones, but there are a lot of star charts out there that you can use to find globular clusters and also open clusters and other deep sky objects that we'll also talk about today. So yeah, don't be afraid to venture out on your own and look at these objects as well.
I think Stellarium is a good one, and even if you don't want to download it on your phone, you can still. There isn't like a website that's used like Stellarium, like a Stellarium web, but you can also download the software.
Yes,
Even
yeah.
but
So
still, most of us use Stellarium.
yeah, so Stellarium is a great resource. I mean, you're able to pinpoint the targets that you want to look at in the night. It also give you information about what's in the night sky as well. So I would definitely recommend Stellarium as a big one. Um, but if you are venturing out in a park somewhere, on a field, or on a camping ground or something, then perhaps you can take a star chart. There's tons of resources online that you are able to get there as well. So um, yeah, so I don't have anything else that I wanted to talk about in terms of the clusters. So what do you think, Zena? Where did you want? Should we move to some nebulas now, or?
Yeah, yeah, it's almost 11. Let's move to nebulas. Nebulas are people's favorites, I think.
Yeah,
Maybe just my
absolutely.
favorite targets.
Yeah, absolutely. So we'll keep the galaxies for the end of the night, just because we want to make sure it gets as dark as it can. And then Zena's right. Let's switch to the nebulas, and which is the first one that you want to take a look at, Zena?
Uh, let's uh, let's do Ring Nebula.
Okay, sounds good.
Yeah, Ring Nebula is a pretty one, and we've had many successes with Ring Nebula.
And the good thing is we're not that far from the Ring Nebula either, because it's right in this constellation Lyra. And I can see it right now. So if I just click on that object,
Let's hope we
hopefully.
can see it even with the light pollution that we have in our campus. Anymore. It's
Yes, I think you know what, maybe I should just search it. I don't want the software to do something wonky while we're doing this stream, so I'm just gonna search it. But yes, Ring Nebula is right over here. It's in the constellation Lyra. So let's slew to that target.
where your Vega is, your home planet. Oh, sorry, did I say home planet? Home solar? It's not a
Yes,
planet.
my
Star.
secret is out. I was really hoping that wouldn't be the case, but
Oh
yes.
no, no, it's all over the internet. No, the government is coming after you. I'm just kidding. We won't.
So
Nobody's gonna tell you secret. Don't worry. We'll keep it safe.
yeah, so just for this target, we're just gonna switch to we're just gonna say change a bit of the camera settings that we're using, um, because I remember when we were doing.
So you're changing the binning. Is that what it is?
Yeah, I'm just changing the binning. I'm just gonna sort of see it so that we can get a bit more light, as opposed to getting that light pollution that we all dread right now. So
So do you go with the high? I keep forgetting with the bin. Usually, I just know with when I do it by hand, but from memory. So if a higher bin means a dimmer object, or is
yeah,
that the
so it's yeah, so the thing is with the higher bin, and I know Zena and I, we kind of demoed, just kind of prepared everything for tonight as well. Uh, the thing about increasing the binning is just so we can uh, uh, just so we are able to at least see the object. Sometimes when we are in a lower bin setting, we're not able to gather the light. Ring Nebula is a bright object, so I really hope that we are able to see it and capture it. And if not, what we'll do is we'll switch to a different bin as well.
that makes sense. So if you were to, so the stars is probably you're gonna do a low bin because stars are very like they're producing a lot of light and they're close to us. They're not really far away in comparison to the other one like a nebula. So nebulas are considered dimmer than a star. If that makes, if I understand this correctly. So the dimmer the object, you want to have a higher bin. You can get more light to collect more light from the object, or is it more details from the object?
Yeah, so there's no one set of instructions which I would say works for binning. I think it's just more about what we are able to see. I mean, as you can see right now, there's so much light pollution that not so much. My apologies, but there's a lot of light pollution in this area, and it's hard for us to get the target inside, and I think it's more sort of let's do a trial and error. Let's see which bin works for us. Let's see which
Yeah.
one does. I think it's almost about just making sure the target that we're looking at is able to work in based on that binning. Um, I think the stream. I'm not sure if the stream has caught up yet or not because I know there is a bit of a lag as well. But
I'm
uh,
quite impressed. Look,
oh, okay, but I hope we're looking at the Ring Nebula now.
I'm so impressed. Like even with this light, like wow,
Oh,
I'm impressed. With this light pollution or the light that's coming from the campus light, I am impressed that we can still see that nebula.
yeah, I'm so sorry. I accidentally hit the reset and it just killed everything. But let me
What?
just allow me to just to fix it up a bit. And Zena, in the meantime, you can sort of talk about the target a bit more. I know this is a target that's really close to you. You've done some imaging work as well, if I remember correctly, or was
Oh
it
no,
was
I
the
did the
different
dumbbell.
one?
I did the dumbbell nebula.
Oh, I see. Yes. Okay.
But no, this would have been great if I was. I did image it, but it's too like it's not as because it's not as close as the dumbbell. So this ring nebula is it's a planetary nebula. So for the audience who don't know about, there's two different types of nebula. There's a planetary nebula, and there is a birth nebula. So obviously, from the name, birth means it's a place where stars are being born. But this nebula in particular, it's called planetary nebula, and it's when a star dies. What it's doing is produce. What you're seeing is that it's producing all of its gas and dust. It's just shedding all of its energy after it dies. So in the center of the nebula, you have a star, the star of a low mass, like our sun, and it goes through a planetary nebula when it wants to switch to a different to its different fate. I don't know if you remember from the beginning of the stream, I talked about the different fates of the stars. So it could either have a black hole, a neutron star, or a white dwarf. So in the case of a planetary nebula, all planetary nebula is just that transition to becoming a white dwarf. I think in this planetary nebula in particular, the center of the star is already turned into a white dwarf, if I'm correct about that. And
Yes.
now that
Yeah,
it's
that's correct.
that's what it's destined to be. And it gives you an idea that all planetary nebulas they came from a low mass stars. So this planetary nebula in particular is 3,000 light years away, which is, if you were thinking about the concept of time, this is how long this object, this light, took to reach our eyes. It took it 3,000 light years to get to where we are. So we're looking at this object 3,000 years back in the past. I'm always fascinated by the concept of time. So if I were to think about how this object is going to look like in the present time, I would think probably just maybe the surrounding gas and dust. Probably it's maybe more expanded. If I were, and maybe there might be more colors involved. Because one thing about like when you the elements of the elements in the universe, they all have a certain color or a specific shade when they are in a heated form. That's why you see those different colors. That's why I like nebulas because they're always so colorful, and the colors reflect a certain element. So when you see the color red or pinkish, that reflects, or you can predict that it's hydrogen. I think. I think like I see the blue or the green in this nebula. I think that reflects oxygen. I could be wrong, but yeah. What else can I tell you
Yeah.
about the
Oh,
nebulas?
oh, sorry, Zena. I was just gonna say, in terms of uh, the object itself. So, I mean, over the decades, the astronomers have noted that this object itself has changed a lot in terms of the expansion and the changing um, and the changes it's going through, and also the glowing gases which you just talked about as well. The really interesting thing about this is that the gases are actually expanding at, I believe, a rate of 30 kilometers per second.
Mm-hmm.
So it's quite fast, and the center, so the center of this object itself, which I hope we are able to see, is that white dwarf that Zena talked about. It's it's about half the mass of our sun, but the surface temperature is roughly 125,000 degrees, and it's 200 times more luminous than our sun. So just that small star, which is that small white dwarf at this point, which is half the size of our sun, is still burning really hot, and it's still brighter than our sun. So that just shows that, I mean, it's the way these stars progress through their stages, it just shows how unique, sorry, not unique, how different everything is. And not everything is the same as it was. So, like, not every star is the same, and not every white dwarf is the same either. Um, so yeah, it's a really nice object to look at, and this is something that's also visible using binoculars as well. So
Yep. Actually, the best thing I like to describe a white dwarf is I say it's a diamond in the night sky, because it's made of just chains of carbon. That's what white dwarfs are. The whole planet. And diamonds are chains of carbon. So the whole this whole star or white dwarf is literally just a giant diamond in space.
yeah, I know that's really something, Zena. So yeah, this was one of the nebulas that we wanted to look at today. I know last week we were having a bit of a trouble trying to see this, but I'm glad we were able to show everyone the Ring Nebula. Uh, so was there another nebula that you had in mind, Zena, or um, what is something else that you wanted to that you had? I know you did have another nebula that you had lined up as well.
Let's do the Swan Nebula.
Okay.
Swan Nebula is pretty. We have seen it before in other sessions, but it's beautiful. You can it's a birthplace nebula. So this one we just looked at, the Ring Nebula, is a planetary nebula. For those of you why it's called planetary, maybe it's just for me because I was always bothered by that term planetary. It's like, why, like, how does that reflect that it says Starbirth nebula? Why is it called planetary when it looks nothing like a planet? And it actually has nothing to do with planet. So Charles Messier, he's the one who came up with that name. When he looked at those nebulas, the first thing he came to his mind, he said it looks like planets. So he called it planetary. But for me, I just find that that's very confusing when it has nothing to do with planets.
Yeah, the terminology is a bit strange out there definitely. I think it's more sort of it does happen sometimes where uh, yeah, we shouldn't be referring to it as the planet, but again, as you mentioned, we have no control over how Charles Messier named it. Um, so yeah, just give me a moment while I make sure we are at Swan Nebula.
Yeah, well, I can give some info about this one while it is a beautiful, honestly, it is a beautiful object. So Swan Nebula, from the name itself, it got the name because it looks like a swan. But there's also other names for it. It's also called the Horseshoe Nebula and Checkmark Nebula. I think it all depends on how you look at it. But for me, I see the swan in there. And so this is because it's an M in there, so that's a Messier object, which means Charles Messier is the one who cataloged it, and I think he did it back in 1764, a very, very long time ago. And this Swan Nebula is in the constellation Sagittarius. I find Sagittarius, the constellation stuff, has a lot of really nice nebulas. Like I'm not, it has nice objects. I feel like there's a lot of nice celestial object to look at in that constellation. And this Swan Nebula is about 6,000 light years away from Earth. So to keep in mind the concept of time, we're looking in the past. So this, what are you going to see once Rohit gets the object in? You're seeing it how it looked like 6,000 years ago. It's not how we look at it now. It's how it looks. We're looking at it how it looked like 6,000 years ago. If that kind of makes sense. I know it's mind blowing, this concept of time with space. And yeah, and if you notice with this nebula, it's so if I were to ask you a question, what are stars made of? I think most of you know stars are made of hydrogen. And guess what's the color of hydrogen in space? It will be red. So a lot of the star birth nebulas, they are, because that's the region where the stars are being born, the nebulas tend to have that red color or the shade of pink because there's a lot of hydrogen in there, because you need hydrogen to create the stars.
Yeah,
Is there anything else you can think about?
no, I think that's a really great description, Zina, and sorry, I was listening to you, but at the same time, I was trying to also clear up everything, and I hope the stream has caught up to where I was. But is everyone able to see this object? I just want to make sure.
Oh, you know what? What else? So maybe, I don't know if we mentioned this before. So how do we see those colors? Like those the colors of the nebula. So it's not the nebula that's producing the color. So we won't be able to see the colors without there is some light shining on it. So in the case of the Ring Nebula, why do we see the colors around it of those gases and the dust around the white dwarf? It's actually the white dwarf. It's what's allowing us to see those colors because it's shining it, or it's radiating it. If that makes sense. So same thing with this nebula that we're looking at, the Swan Nebula. So there is the reason why we see this red color is there is a cluster. There's a cluster of stars in there, and it's those stars that are producing the color or showing us the color of the sun, which is or producing that red color.
Yeah, and the other thing about this object itself, uh, and also some of the other star birth regions, that these objects are actually quite young. I mean, this object, the age is approximately 1 million years old, so relatively young in terms of the scale of the universe,
Oh
and
wow!
it spans about roughly 15 light years in diameter. So in terms of light reaching from one end to the other, it takes about 15 years, as opposed to, I know we were looking at a cluster which is completely different, globular cluster before, but where light going from one end to the other can take up to 84 years. So that's how different objects they are in the night sky, as opposed to um, that's how different these objects are in the night sky, because some of them they're younger, and some of them are older, some of them are burning hotter, some of them are burning colder. So so yeah, it's just fascinating in terms of how many things we are able to look and see, and I'm actually really glad that it did come out as it did, because
Wow!
um,
Yeah,
I was a bit afraid in terms of the light pollution that we have right now, and I do apologize for the lights, but
not the one who brought those campus light.
yeah, yeah,
That's the fault. I know
yeah,
it's for safety, but what can we do? I
yes,
don't know if it's just with me, maybe with you as well, Rohit, but every time, like I've seen this object many times, this Swan Nebula, or the same thing even with the Ring Nebulas, but I feel every time I look at those objects and the clusters, I see something different. Like I see a different shape. Like for this one right now, even though like last time when I saw it, it looked like the swan. This time it looks like a submarine. I don't know why. Or maybe a fish. Do you see that? Or maybe you see the swan. I don't know, but I don't
Yeah,
see the swan.
I feel like we make representations of night objects based, like obviously the way we perceive it in our eyes. So I think for me today it looks like a submarine as well. I think I'm in that boat. I know.
No pun intended.
Yeah, I'm in that boat. Yes, that's absolutely right. And then I know in the chat, I know Abby just mentioned it does look like a swan. So maybe our eyes are playing some games on us. Um, but yeah, so this was this one nebula, and I just wanted to show one more if we can. Uh, so so what do you think, Zena? I mean, I know we're about 15 minutes out from the end of the session, end of the stream for today. I do want to see if we are able to look at a galaxy today. So
Great.
do you
The
think we
galaxy.
can? Yeah, do you think we can maybe try one more nebula, or did you want to move on to the galaxy itself?
Now let's move on to the galaxy. I think
Okay.
if we have extra time at the end, or if we can't see the galaxy, then we can do another nebula.
Okay, that sounds good to me. Um,
All
so
right, which
so Zena, I just wanted to let you know. Matt just said in the comments that if you asked Messier, it probably looks like a comet to him. So
That's a good one. I like it. I just saw it. Good one, Matt. Yep. You know what? I agree. Charles Messier will. You know, and it totally does. That was actually very interesting. We should have screenshot that one. This one. It totally does look like a comet.
all right, so let's move on to Messier's M64, which I believe is the Black Eye Galaxy. So yeah, we're gonna see how this one turns out. I know we are going in the opposite direction, so perhaps we will get lucky and we won't have the effect. We don't have we won't have that many prominent effect of that light pollution, but let's see how it turns out. And see, that's the other thing as well. When we are using a telescope which is connected by software and everything, uh, the telescope moves quite fast in terms of getting to a place. Uh, but then it's also about the stacking of the images and stacking of the frames that sometimes can take time. But I think we're there now, so let's see what we are able to capture.
You know, the black eye. I keep calling black eye nebula. Is there a black nebula? That I don't think there is. But I think there is an. Is there? Is
I
there a
I
black eye
honestly
nebula?
do not know. Maybe there is. Who knows?
Yeah, I feel there is an eye nebula somewhere. There should be an eye nebula.
Isn't there a
Anyhow,
cat's eye nebula, Zena? Isn't I think it's called isn't it called cat's eye if I remember correctly?
maybe.
It's called or is it a yeah I feel like there's a cat's eye somewhere. I'm pretty sure. But anyways, let's go ahead to this one.
Yeah, I hope we can see that one, the black eye galaxy. It's it's like if you were to look up the Hubble picture, it's like this is just this galaxy is just fascinating because I'm so fascinated with like in terms of all the galaxies. There's like the face up galaxies and there's the edge on galaxy, and this black eye galaxy it's like in between. It's in between an edge on and a face up. So it's again like it gives that 3D effect when I look at it. So maybe that's why I'm really into it. Maybe I don't know. Maybe there's a theme with me. I like 3D more than 2D. Yeah. So this we're seeing something. So this black eye galaxy is 17 million light years away from Earth. And if we were talking about the classification of the galaxy, would be a spiral galaxy. So there's three different types. There's like elliptical galaxy. There is the spiral galaxy, which is the one we're seeing right now. Our Milky Way galaxy is an elliptical galaxy. Oh, sorry, no. Sorry, I take it back. Our galaxy is spiral, and the other one is called the irregular galaxy. It just doesn't have a specific shape.
Yes,
And
that's correct. Yeah.
same thing with galaxies. Like they also have ages. Apparently, it's it's believed that galaxies they change shape according to their age. I could be wrong about this. Honestly, the best person to talk about galaxies and classification of galaxies, it would be Joanna. So I think that's what was her PhD was all about. It's all about galaxies, so she would be the galaxy enthusiast. But
Yeah,
yeah, with the
so sorry, Zina, I was just gonna say we are getting something. I know uh, I know we're getting a bit of the details, but I don't know if we're getting all of them. If I remember correctly, the Hubble image really picked out the clouds around the galaxy as around the
oh
center as well, and we can kind of see an outline of this. We can see a bit of what's happening here, and it's maybe we'll get and maybe it'll improve with multiple stacking, but unfortunately we are having some stacking issues as well, which it does happen. However, I still think we are able to at least something. I mean, we're able to see the core of the galaxy, which is something I didn't expect,
yeah,
and
and
we are able
so
to
bright.
see.
Like the core is very bright, and you can see it's kind of like you can see it's not face up or an edge on. It's like in between. You know what I mean?
Yeah.
It's not edge on, but it's not completely face up. Like you can see that kind of structure how it looks. Honestly, I totally recommend looking at the Hubble picture for this one. You know,
Yeah,
if you
and I'm gonna do my best. I'm gonna do my best to kind of remove away this blue as much as I can, just so we are able to at least see, not look at the blue object, obviously, but we just have to keep in mind that we are careful in terms of not overblowing the proportion in terms of the colors. So um, I mean, I was able to remove the blue a bit, although I don't know if if that changed much in terms of seeing anything. But yeah, we are able to see it, which is great because honestly, it's been a while since I've looked at a galaxy from our telescope. So it's nice to know that we're still able to do that.
oh, absolutely. Yeah, I'm very impressed. So, one another reason why I like this galaxy is that it has a very strange behavior in comparison to other galaxies. So, usually, if you think about the gases and the stars, so they all rotate. They all rotate in one direction. So you have the gas in the inner. When I say inner region, that it means they're closer to the center of the galaxy, and you know what's in the center. That's your black hole. And you also have the gases that's more in the outer region, which means they are further away from the center. So with this galaxy in particular, the gas in the outer region rotates in the opposite direction of the gas in the inner region, which is not common with other galaxies. So one of the theories why this galaxy is behaving as such is that they think this galaxy already merged with another one.
Oh,
Yeah, so they believe this galaxy is already a merger galaxy.
well, that's interesting. I mean, I didn't know about this, so that's really cool. Thanks for sharing that, Zina.
Oh, no worries.
Yeah,
Another,
so
this is called the Evil Eye or the Sleeping Beauty. I don't know why they give those two completely different names. Evil Eye, Sleeping Beauty. I don't know why. Where those names are coming from.
as long as we don't call it a comet, I think we're okay.
Oh my god. Yeah, good one.
I feel like that'll be a running joke for the rest of Starry Nights. We'll be referring everything to as a comet.
Yeah.
So yeah, was there anything else that you wanted to talk about for the Black Hat Galaxy, Xena and Messer 64?
Let me think. No, I think I'm good. No, I think I
Okay,
already.
if you don't, I do have another galaxy that I wanted to try, and I don't think it's that far from where we are right now.
Oh,
So
cat's eye.
yeah, I want to try that one. Yeah, let's see if we can. I mean, maybe we'll get lucky twice. Who knows?
Yep. Let's do it. Yeah, we there's an I just realized there's an eye theme in the galaxy list that we have. Black eye, cat eye. Do we have
uh,
another eye in there?
well, remember. So Matt did confirm it for me in the chat. There is a Cat's Eye Nebula as well. So
Okay. That makes
so
sense.
so yeah, that there is that theme
Yeah,
there.
there's got to be an eye somewhere in the nebula. I'm sure there's a nebula that when someone looks at it, they think of an eye.
Okay, yeah. So I mean, we're at M94, which is the Cat's Eye Galaxy, and let's see how this one turns out. I have everything crossed at this point. I really hope we can see something.
I have,
Um,
I don't remember how it looks like. Like I don't know if I've ever seen it with our telescope, like the Trottier telescope.
yeah, so I remember observing this object. I believe it was one of the camping trips that I did in Merritt, just to one of the s- so a lot of the times in close to the summer months, or sorry, in closer to August, we'll have this Merritt Star Party, which is done in close to Merritt, BC. Um, and I remember seeing it from there, and because we are in a dark sky area where you look up and you can see the Milky Way right above your head. So I remember seeing it there, and it was just fantastic. But I'll do my best to clear it as much as I can. I mean, we can already kind of see the center, the
Right.
core of the galaxy. So this is the spiral galaxy itself, and it's approximately 16 million light years away from us. Um, but just bear with me while I clean it up as much as I can, and then we'll see what we can observe.
That's amazing. That's wow. That's actually very very nice. I like it. I'm quite impressed with our telescope how we can still see very far away objects, and yet, like you would think, far away object would mean they are faint, but we can still see them regardless of the light pollution that we're dealing with.
Yeah, absolutely. Th- they are. I mean, we do have. It's just that because of the light pollution, there's also glares that comes from the other areas, and that also affects the view. But yeah, I have a feeling I'm not going to be able to get it as clear as any more than this it is right now. But yeah, so
Impressed. So
yeah.
I like.
So the interesting thing that I really wanted to discuss, and I was hoping we would be able to see the image of the galaxy, but the inner distance between in the galaxy itself, um, excuse me, the inner distance is approximately 5,400 light years away, but the outer distance is 45,000 light years away. So this means that in the inside part of the galaxy, it'll take, as we've discussed throughout the stream today, it'll take about 5,000, 400 light year, 5,400 years for light to get there from one end to the other. But for the outside, it's 45,000. It's it's 10 times that amount almost. So it just shows how big these objects are, and the scale that they are at. Yeah, I'm still trying to clean it up as much as I can. So,
I'll be honest with you. As beautiful as this galaxy looks like to me right now, it doesn't look like a cat eye. It looks like a flower.
yeah, it doesn't. You're right. Perhaps this one dot can represent the cat. I'm not really sure, but you are right. We're picking up a bit of details. I mean, it is a spiral galaxy, so I was really hoping to see some of the spiral arms, but we can. I mean, I feel like if we had multiple stacks, then perhaps it would have gone in that direction. But yeah, do you think, Zena, that maybe we can show another nebula, as we did get a lot of luck with nebulas today?
We can. There's only 2 minutes left, but sure, we can do
I
it. Do you
think
think?
I think we'll be quick. We won't take that much time.
Let's show the blinking eye nebula. I
Okay.
know since Abby's here, this is her favorite one.
Oh, okay.
Abby,
I didn't know that.
want to take it over? You can talk about that one, Abby.
Yeah, you we'll get Abby to describe the entire object in the chat box, as opposed
There you
to
go.
us rambling on and on.
I mean, I can say a few things, but I don't want to take away from Abby because I know how much Abby likes this galaxy. That's a galaxy nebula. Sorry, I meant nebula. Now I'm getting mixed up between those two with the name.
That's okay, Zena. It's closer to the end of the day. No, I understand it happens, but no, we are definitely looking at an nebula itself.
Yep. Yeah. So this galaxy. Oh my God! This nebula is 2,000 light years away from Earth. So keep in mind, this we're seeing this nebula, how it looked like 2,000 light years back. No, did I say light years? 2,000 years ago. That's what we're looking at, and it's in the constellation Cygnus, the Swan Nebula. Oh my God, what is wrong with me? Okay, you're right. It is the end of the night, and I'm mixing up the names right now. The Swan constellation.
Yeah, so it's in the constellation Cygnus, which we know as Cygnus the Swan. That you're right. Yeah.
So much familiar. I didn't realize how familiar the names between the different types of objects. Wow.
I
And this
mean,
was
and it's also because we looked at the Swan Nebula today, right? So that's still fresh in our minds.
exactly, exactly. Yeah, yep. Yeah, that's why Abby, you should take over. You should explain why is it called the Blinking Eye Nebula. I know that was your thing.
I mean, we'll have to see how much we can see because at this point, Zena, unfortunately, we're not seeing a lot. But let's see. Maybe I'll have to just kind of.
I know last time me and Abby were so lucky, and we actually did end up seeing it. Well, let's hope
Okay.
for the best. Fingers crossed.
Okay.
And
You know what? I'm just gonna switch. I'm just gonna quickly switch the binning, and we'll see what comes out. Because I think for the nebulas we were at different binnings. So let's try that. Maybe we'll get
that's
lucky
interesting.
and see what comes out.
But what if you were to look it up? It does. It looks like so with this nebula, if hopefully we can get to see it. But the reason why it's called Blinking Eye Nebula is that it feels like when you do averted vision, when you look away from it, it twinkles, or it looks like it's blinking. That's why it's called Blinking Eye Nebula. Or is Abby explaining it? Oh, there you go. She's explaining it. Awesome.
Yeah. So there we go. We have
Oh, there
something.
it is. We see the green. This is I like how green this nebula is.
Okay, and I know we are over time, but I assure you this is not going to take that long.
This is very good. Oh
We'll,
my
we'll, we'll
God.
do our best to wrap it up very soon. One thing I just wanted to mention is while I'm just kind of adjusting everything is if you are here to just remember to email SFU Science Outreach within 24 hours just to get credit for the telescope program. A short summary of what we looked at today. We looked at Altair, we looked at Deneb, we looked at Vega, we looked at M3, we looked at M56, so globular cluster, and then we looked at open cluster, which was the M39. We looked at Ring Nebula, we looked at the Swan Nebula, and now we're looking at the Blinking Eye Nebula as well. And then we also looked at the Black Eye Galaxy, and we didn't see, unfortunately, the Cat Eye Galaxy. So yeah, in case if it does come up, just for the credit for the telescope loyalty program. So yeah, this is the last object for the day for tonight. It's the Blinking Eye Nebula.
That's beautiful. I like how we ended it. We ended it on a good note. On a good high.
Yeah, absolutely. So once again, I just want to thank everyone for coming today, and a big thank you to the moderators, Matthew, Abby, Haley, who were able to come in and help out in the chat. And again, thank you, Zena, for your great insights
Worries. Thank you.
regarding the galaxies.
It was great working with you.
Yeah, same here. So.
Finally,
Yeah, so we are scheduled, I believe. Sorry, so I was just gonna say for the future Starry Nights events, just please keep an eye out. You'll hear a notification next week if it's going through or not. Um, and uh, uh, and thank you again, everyone, for coming. And have a great night and stay safe.
bye.
Bye, everyone.